Hello everyone, can you hear me? Kasam?
Yes, Vikram.
Cool. So shall I start now?
Yes, Vikram, sure. Guys,
Okay.
request you all to please be on mute during the session. Uh, yes, Vikram, you can start.
Okay. So hello everyone, my name is Bikram. Today we will have a short introduction to blockchain. Okay. So let's start with what is the current situation with blockchain. There is so much of buzz about blockchain in the world. Almost everyone is talking about blockchain, but blockchain is not a silver bullet to all the problems in the world, but it is certainly a revolution. Okay, so we need to understand where exactly blockchain fits in, and not try to solve every problem in the world with blockchain. So that is what it means. Before we get into the details of how exactly a blockchain works, what are the various flavors of it, and to have a deep dive into the technicality, we should first understand a little bit of history about blockchain, why at all it came to the world, and why it has taken the entire IT industry by storm. Almost every use cases, people have started thinking if blockchain can benefit their business, right? So it dates back to 1970s around, where in the telecom industry we had something called circuit switching. So if somebody wants to call somebody else, then there had to be somebody in between who would establish that connection. Otherwise the call wouldn't happen. You cannot really connect with the other party unless a dedicated connection is established between the two of you. So that was called circuit switching, right? And it was very, very problematic, because you always needed somebody who would mediate your communication, so to speak. So after that, TCP/IP came into picture to achieve open system, so that the it was a switch from circuit switching to packet switching, so that it will have the destination's address, right? The socket address, IP address, and port number, so that you can literally connect to anybody and everybody in a peer-to-peer fashion. You really need not need an intermediary like you used to require in circuit switching, so that this time you can connect to anybody. You just need to provide the destination address, right? And with the with TCP/IP as the base, Sir Tim Berners-Lee imagined WWW back in 1990s. Okay, so entire World Wide Web is actually based on the TCP/IP system, which was designed to be peer-to-peer. Okay, now people used internet for information exchange and took their business to the next level. So we had the dot-com bubble also during the 2000s, but now talking about the revolution of the internet, how it revolutionized the entire industry, not just IT, almost every business function. It took the business to the next level. People could share their information with their websites, etc. A lot of transactions happened through websites that way. And if you compare this with the older barter system, so barter system was something where if I have, let's say, vegetables and you have fruits, then for a certain quantity of vegetable that I give you, I get in exchange certain quantity of fruits, right? If I have, let's say, wheat and you have green grams, we could exchange, right? So here, if you see, transaction is equal to settlement, right? If I give you something, I get something in return immediately. So this is transaction and settlement are not two different phenomenon. It's one and the same thing, right? But in the internet, when we transact something, is it transaction is equal to settlement? No, because if you transact, let's say, $100 to my account, then it goes through a settlement process. If you buy stocks of Intel or Microsoft, then that settlement, it takes T plus 3 days, transaction plus 3 days. So it takes time. Transaction is a different thing. Settlement is a completely different thing. Now, if you take a bird's eye view on the entire internet, so how has it really shaped up? Back in 1990s, when we had TCP/IP, and on top of which Sir Tim Berners-Lee imagined the World Wide Web, and how that was imagined, and how it has become today. So when I go and shop something from Amazon, let's say you are the seller of an item in Amazon platform. Somebody is a seller in Flipkart, right? So WS Retail is a Flipkart, but you could be anybody, selling anything on Flipkart as a platform or Amazon as a platform. So if I am buying something from, let's say, Flipkart or Amazon, I don't trust you because I don't know you, right? But I am still comfortable when I sit back and relax at home because I have ordered an iPhone, say for example, from Amazon. But then it's like, a lot of money that I have paid, but I still feel secure because I trust Amazon, not the seller who is selling on the platform. So Amazon has won our trust, and because of which Amazon is benefiting, being a centralized platform which facilitating the transaction, isn't it? If I transact something, if I say that I have transferred $10,000 to your account, you don't really trust me. But when you see that in your account some amount has been credited, then you actually trust your bank, right? You don't trust Bikram. I'm Bikram. You don't trust me, but you trust the bank because you see that money in your account, right? So whatever picture is shown to you, you trust it because you trust the bank, isn't it? So this is how the internet has shaped up eventually. If I have to send an email to you, I need not use Google or Microsoft, right? I don't need Gmail to send you an account. I can very well maintain my own SMTP server and I can send you an email. That's pretty much possible because it is based on TCP/IP, our communication stack. Uh, but today, it is like so if you see for emails, right, there are some trusted entities like Yahoo, Microsoft, Google. They have taken this entire segment. If you think about the e-commerce business, then you already know the giants that are there already, right? So Amazon, Flipkart, and whoever is doing online business. So the entire system has become like this because we are geographically separated. We are in different locations, and I have not seen you, I have never interacted with you. How can I even trust you? But still I trust Amazon, so I feel safe when I do a transaction online, isn't it? So this is how the internet has shaped up, and technology, I would say, that probably was not capable enough to facilitate a peer-to-peer transaction where settlement is guaranteed, isn't it? So I do not really need a bank in between if I want to transact some money to you. And this is exactly what Satoshi Nakamoto, a person or entity that nobody knows, who coined Bitcoin, right? So this people say that this completes that internet puzzle because you are able to now transact Bitcoin or anything of value online through the internet, and rest assured that your transaction will be settled, right? You don't need somebody, an arbiter, a trusted arbiter like a bank, who would say that, hey Bikram, don't worry, I will take care of your transaction, right? I say that nobody needs to take care of anything because I am a part of the network, and I better handle my business, and you better handle your business, and we don't really need a centralized intermediary, right? So, if we compare the legacy system versus a blockchain-based decentralized system, so on my left on the screen that you can see, we have a legacy system which is centralized. A typical bank or any, let's say, or a broker, who ensures that your stocks are settled, because you do not go and buy stocks from Intel, right? You don't interact with Intel, so there is always a bank or a broker in between who would settle your transactions. So you see that the centralization of power, single point of failure, no transparency in the system, because today whatever you see in your account statement, it is something that the bank shows you, right? If there is a 50 cent missing, trust me, you would never know it. Okay. And then all the fraud, misuse, corruption, because it's when we have centralization of power, centralization of money, people are things are managed centrally, then there is a lot of things that can go wrong, isn't it? So now if you compare this with a blockchain based decentralized system, then it is decentralized. You see, there is no center here, who would settle transactions, so to speak. No single point of failure, because the entire network doesn't depend on one or two nodes going down. Okay. Because there is no center. And then greater transparency in the system. Now this is something to ponder upon at this moment. When I say greater transparency, why? I mean, what do we really mean by, that we will discuss. But then it is the entire system is very, very transparent. That means that you pretty much see anything and everything that is happening in the network. But why? That we will discuss. And this is immutable and secured. Immutable means you cannot change anything, and it is secured means how it is secured, that we will see when we take a deep dive. Okay. And there is a disclaimer here that says that there is almost no system that is purely centralized or decentralized. And why do we say that? We will learn that in few slides. Okay. Now, how does a decentralized system work? In the previous slide, we learned that there is transparency, right? What kind of transparency here that we're talking about? Now, there are three diagrams here on the screen. In the step one, what has happened is, so Genesis block is something that is the beginning of the block or beginning of the transaction. Genesis means the starting point. Okay. Now, just for the sake of simplicity, for easier explanation, let us assume that Alice had $50 in her account, okay, and that information is known to everybody in the network, right? Now, uh, how else could a decentralized system work? We are saying that we do not need a centralized server, because we are hoping that we all of us together can maintain a network, right? And that is why we do not need a centralized intermediary. Otherwise, we would need one, because there would be disputes that would require settlement, right? So here, what we are saying is, instead of a centralized server taking care of all the transactions, we say that we hear all the transactions, we learn about all the transactions. Otherwise, if you don't know of a transaction that has happened in your network, how can you help resolve that dispute? You cannot do that, right? You have to be equally knowledgeable, you have to be an active participant in the network, and you need to know anything and everything that is happening inside your network, right, that you are a part of, so that you can help maintain that network. So that way, here, Alice, Bob, Charlie, and Dave, the four people, together, they, so to speak, they formed a consortium, and they are maintaining this network. Okay. Anything that is happening, all of them are aware that something like this has happened. To give you an example, if you take a look at the second figure, where Alice is transacting, let's say, $20 to Bob, then you see that the transaction is a broadcast in the entire network. Okay. Now, Alice paid Bob $20. That is an information that everyone is aware of now, right? Everyone knows that such a transaction has happened. Now, tomorrow, if Alice said that, I never made a transaction of $20 to Bob, then the network will say that, Alice, you're lying, because we all know, we all heard, right, that you had made that transaction. Alice used her cryptographic signatures, right, so that tomorrow Charlie or Dave, all of them can say that, hey, this is a genuine transaction, because we can validate your signature and we can see the amount that you have signed that you are giving to Bob. So I think you have made the transaction, and you cannot say that you have not done it if you have done it, isn't it? So that is how the network works. Any transaction that is happening, you see that the personal ledger that all these participants are maintaining, it is getting updated with that latest transaction, right? This is exactly how a decentralized system should work, right? If this is not happening, then probably you would have to fall back to a centralized system. Otherwise, who would solve disputes? So all of you together have to solve disputes. Now you might ask, if this is the case, then if everybody knows how much of money I have in my account, then I'm vulnerable to attack, right? Physical attack. It may not be a cyber attack. If I disclose how much bank balance I have, and if I really have a lot of money, then probably you'll come and kidnap me, right? So this is a possibility. Things can go wrong, and this is precisely the reason in Bitcoin. So I wouldn't steal the thunder of the Bitcoin concepts, because we will have that as a separate session. But for now, just to give that clarity to you, in Bitcoin allows me to create a lot of pseudonymous accounts, accounts that I own. So it is like in the figure that you see Alice, right? It could be an Alice's account, not Alice himself, right, or herself. So Alice is somebody, and that somebody is maintaining so many number of accounts. So it is like every time I create a transaction, I created or every time I have to get some money from somebody else, I create a new key pair and share that public key with that person and get the amounts in that public key, right? So and tomorrow when I want to get one more transaction, somebody has to give me some money. What I do is I create one more key pair, one more public key and private key pair, and I give that public key and get some amount there. So it is like whenever I want to spend those transactions, right, I have to sign with my corresponding private key. So Alice has all those private keys of all those accounts, right? Now, if in the network, being a part of the network, you would know that certain account has that many number, that much of cryptocurrency, or that much of Bitcoin, or that many number of dollars, right? But you wouldn't know that that account belongs to Alice. That is how it is pseudonymous. It's not completely anonymous, so to speak. But now we will dive deeper into the technicality later. But that is how the network can be maintained. Okay, that makes it secure. You can be secured that no one really would know that how much of money you have in your account. Okay, because you own that account, but nobody can link that account with your physical identity or the real world identity. Okay. All right. Now, to understand blockchain, right? So there is a perspective. When we say a decentralized network can be built with or without blockchain. Okay. So we should really be a fan of decentralized network because there are some inherent advantages to it. And why blockchain? That also we will see. But then, first and foremost, we actually need to understand what is a decentralized system, what makes a system decentralized, right? So the founder of Ethereum, Vitalik Buterin, he explained it very beautifully. Okay, so this is not what I am saying, this is something that he is saying, and this is a standard, I would say, in the market. How do you really envision a decentralized system? Okay, so there are three perspectives of looking into it. One is a technical perspective, the other is a political perspective, the third one is a logical perspective. So technically, when do you call a system decentralized? A system can be centralized or decentralized from a technical architecture point of view. What we consider is how many physical computers or nodes are used to design a system, how many node failures can it sustain before the whole system goes down. Now, you might be thinking that this is something similar to a cluster of machines, right? Where we have a disaster recovery or failover cluster. If one node goes down, the other comes up, right? So it is pretty similar to that. So technically, we want the system to be decentralized when the system doesn't go down when one or two or five nodes go down, right? Political perspective means that who controls this system, who has the reins that controls the system. Okay, it could be an individual, it could be a group of people, or it could be maybe a technical account, say for example. Okay, anything or any entity or any item or any human being or a group of people, if that is controlling the system, they have the power on the system, then that system is politically centralized because somebody is controlling that system. Okay, now if that is not the case, then it is politically also decentralized. We will discuss about certain examples to clarify these points, but let us now move on to the logical perspective. So a logical logically, when we say a system is centralized or decentralized, depending on how it appears to be. Okay, whether it is technically or politically centralized or not, you would see that a system is logically decentralized if it appears to be decentralized in the first place. And the second point is that if you let's say cut the system into two halves, then those two independent entities should also function. I'll give an example. Let's say that you're downloading some movie from torrent and there are so many seeders seeding, right? And then if certain seeders of, let's say, America, they kind of stopped seeding, or some regulations came in, all the ISPs blocked those packets or blah blah blah, then something happened like that, then also there are other seeders and there are other consumers, right? So anyone can be seeding and anyone can be consuming from them. So that makes the system logically decentralized. Okay, now I'll give you another interesting example. We all know that we have a concept called content delivery network, CDN, right? So if I want my for a simpler example, if I want my website to be very very fast, then what do? The heavy components that I have in my website, I offload that to let's say that I'm consuming Amazon's CloudFront service, okay, AWS CloudFront service. So CloudFront is a CDN service, and that could be so basically Amazon could be having their data centers in London, in UK, in Mumbai, in India, or let's say Singapore, or Australia, or in the US, right? So they can have so many servers, and I'm consuming that service so that my website becomes fast. So what I do is I host the heavy components of my website in all those servers, right? So if somebody from India is browsing, then if the India server hosted in Mumbai is serving that request, then it will be a lot faster compared to it being served in UK, or it is if it is being served from US, then it would be the latency would be a millisecond more, isn't it? Because US is pretty far, right? So the closer my system is, the better uh, efficient it is, because the time consuming, the time that it would take is less, right? But if the India server goes down, then nobody stops. Let's say if somebody is trying to access my website, they can very well be served from UK. They could very well be served from Singapore. They could very well be served from Australia, or if not none of them, then maybe from US, right? So nothing stops it, and that is the benefit of having a CDN network. Consuming a service of CDN network. You see, it is pretty much decentralized. There is no blockchain in here, but my request could be very much served from any of these servers, right? Because I have taken the service from Amazon. Now this is politically centralized, because tomorrow, if Amazon pulls the plug, Amazon says that I no more do this CloudFront service, I am closing it down, I'm shutting this business down completely, then you don't have a choice. Everything goes down, right? But technically, if you see, it is decentralized, right? The language of communication. Right now, I'm presenting in English. All of you can understand. This is another example of a system which is kind of decentralized in every way. If I am saying you are understanding, bingo, we are done, right? If some country bars English as a language, then also we can still talk, right? So nobody really controls it, right, that way. So these perspectives are extremely important to understand in designing real world blockchain based systems. Okay, so this is something that I will explain in a little while in the further slides. So what is blockchain? So far we have discussed a few things, but what exactly is blockchain? So here, we would be taking an outside in perspective. When I say outside in perspective, we should first try to understand the use cases where blockchain could be beneficial, and not straight away dive deeper into the technicality. Okay. And why do we do that? Why do we say that let us not discuss it technically? Because blockchain is not a single thing. Blockchain is not a single topic. It has its roots in cryptography, in game theory, and in computer science fundamentals. Okay. So it's not just one thing. You see, all these three fields are research areas in themselves, right? But blockchain is a combination of all three, I would say. And this is the reason we should understand all these technical components, at least at a decent level, to be able to stitch them all together and form our concrete understanding of blockchain. Okay. And that is the reason we take the outside in perspective, where let us first understand the use cases where blockchain is beneficial, where blockchain is not, and then we understand these three components, and then we stitch them all together and build a complete understanding, and then explore further use cases on how really Bitcoin works, how really Ethereum works, how really Hyperledger works, or other blockchain flavors work, right? Or possibly you can build your own blockchain system ground up. Right. So as promised, we are discussing now the use cases of blockchain. Okay, and Bitcoin is the very first use case of blockchain, because all of you know that it was kind of being worked upon in the year 2008, and in 2009 it was launched, and ever since it has stood the test of time, and it has proved that it is there is no center in here, but the system can still work. Despite knowing that So I'm not getting into game theory at this moment, but there is a point that I would like to make here is, you know, in this decentralized network where, we say that together we are forming a network and we are maintaining this network and this will go on forever. The first thing, so this is a kind of public blockchain that we're discussing because anybody can join, anybody can live, and Bitcoin is one example. If you want to leave this network tomorrow, then you can very well go ahead, stop being a node in the network. You could do that. But then the question that we must ask ourselves is, what is it that stops you from not playing by the rule? Okay. Or what is it that stops you from playing by the rule? Okay. Could there be a benefit if there is something that I do, be it unethical, be it fraudulent, and if I am benefiting from it, probably I will go ahead and do it, right? Now, despite knowing all these, that people might try to do fraudulent transactions, and what is it that you keep in mind so that despite all those possibilities existing, still this Bitcoin node works? Still today, it is sustainable, it is working, it is hack proof. It has stood the test of time for so many years. Trust me, when it is decentralized, it is so much open to public. Almost everybody would be trying to hack it in some way or the other, right? But it is still strong. It is still there in the market, and it has proved that this concept can really change the world in certain way. So now a Bitcoin node is a part of the network that allows Bitcoin to operate the way it does, right? Blockchain is a distributed ledger technology. So few people, for few of you who might have this question, what is the difference between Bitcoin and blockchain? So blockchain is actually the technology. So when we say blockchain, we're actually referring to the technology. And when we say Bitcoin, it is one of the cryptocurrency use case of blockchain. Okay, that should be our understanding. Then blockchain is transparent, open to all nodes in that chain. It is distributed. It is decentralized. Bitcoins are discovered rather than printed. Okay. Now, how does new Bitcoins get generated? The only way new Bitcoins get generated is they are mined. So here there has to be a compensation mechanism if you are maintaining a node to help Bitcoin community stand, to help Bitcoin network stand, and for it not to fail. If you want to contribute, then what is it that you must get, right? Because if you are not getting anything, then you would say that hell with it. I don't really want to consume all my resources, run a node, consume electricity, CPU cycle. Why would I do that if I don't get benefit from maintaining a node, right? So there is a mechanism that is that is enforced in the network, so that if you are trying to maintain the network, then you get certain benefit for maintaining the network, and that is why you do it, right? Okay, so likewise, this is a Bitcoin cryptocurrency use case of blockchain. Then the other example use case is supply chain, where you must. It's in the news that Walmart is is implementing blockchain-based network, so that there is a supply chain track and trace. So in the entire world, supply chain is an area which is full of disputes. There are so many payments defaults. There are so many damages. People say that I never received the item. Why would I pay, right? And then so many disputes in the supply chain because there is no proper way of maintaining transparency in the network. You see, there is a factory where certain items are being manufactured, or there is a farmer, let's say, manufacturing cabbages or carrots. From that level till it lands in, let's say, the cold storage, or the how do I put it, let's say an outlet of Walmart, right? Where those cabbages are being sold. It travels through a journey, right? There are so many distributors, dealers, transport agents, CNF agents, stockists, and whatnot, right? So how do you really maintain the track and trace, the traceability of the items, starting from its provenance till, let's say, you buy it and it ends up in your fridge, right? So if you want to maintain that level of transparency, despite knowing that there are so many levels in between, then could you really do something so that you can trace back the origin of that product, right? If you are eating something, then there are use cases that people are working where if you are eating cheese, then from which farm all the way to the cow that produced that the milk. You want to have that traceability. If you are eating cabbage curry, then in which form, which farmer produced that? That level of traceability, if you want, then how could that be possible, right? Now, one thing that we must understand is you may not be able to build one centralized infrastructure, right? Because technically it is more feasible to maintain everything through one server, right? Through one entity. Probably Walmart would say that I will dictate the terms. Let me build a centralized server, and I will let all of you consume from it, right? So Walmart would have that monopoly, right? They will have that supremacy in the system. They can, if they want to change something, they can do it, right? Now we don't want that. We want, because there is a supplying company. There is a separate entity altogether, probably as big or in par with let's say Walmart, because that company is probably supplying to many different vendors like Tesco and whatnot, right? So they're supplying to so many people. Now they cannot be owned by Walmart, right? But they can. They agree to form a consortium that benefits everybody. Say for example, right? So you form a consortium, and then the things that needs to be kept transparent, you make those things transparent. Other things you don't, you keep that with you. To give an example, if I say that I'm a supplier, I procure vegetables from farmers and I will supply to Walmart. For the sake of simplicity, let's consider 3 levels here. Okay. Now, what I want to keep transparent is my stock, okay? So that I really have this many tons of cabbages in my in my stock, in my godown. But I mean, I want to give that information to Walmart. I want to keep that transparent, but I do not want Walmart to see for how much price, for what price I am procuring those vegetables or those cabbages from farmers. That is confidential to me. How much margin I am keeping, that is none of Walmart's business. I say that I will have control on it, right? So if I want to do that, then those things are also possible, right? So here we could also discuss on what kind of blockchain can be used here. Is it wise to fork Bitcoin and develop on it, or is it wise to have Ethereum blockchain, a private version of Ethereum, Ethereum blockchain, or should we build such a solution on Hyperledger, right? The Linux Foundation's Hyperledger. So we could use any of that, but it depends on which blockchain would you use. You would use the one where your development efforts are less. Obviously, for a particular use case, there has to be a lot of customizations that you have to do depending on the business requirements. But you would probably choose a blockchain, so that most of the work is already done with little or minimal changes. You should be able to spin up a blockchain network. You would probably prefer that, right? Or if you want a completely custom blockchain, you could write one from scratch as well. Okay. Right. Another interesting use case that I was consulting with a company in the last few months. So I thought I will share this use case with you. So what this company does, without consuming much of time, what I would like to explain is, today we are getting all our data. So this is a different use case. Okay. Now this is not a supply chain use case anymore. It is a different use case that I'm going to walk you through. So a company, is building a solution where the financial data or the healthcare data, and after GDPR, General Data Protection Regulation in the Europe, things became very, very strict. Even India is working on something similar to GDPR, where these information houses or the data powerhouses like Google, Facebook, they cannot just do anything and everything with your data, right? The idea is to make you owner of your own data, right? So because of that, there are a lot of regulations that are coming in, and there are so many use cases being developed, and that will be in compliance with GDPR, etc. Right? I just thought I should tell you that may not be fully relevant to this use case, but yeah. Now, what this company is doing is the financial records that you are getting from your banks. Okay. Today we get everything on our Gmail or Hotmail or Outlook or whatever, and because of which we are more vulnerable to attack, because it is kind of an open network. I can get a phishing attack email, right? So I click on it, I punch in my details, and everything is gone. So that is a possibility Probably you and I have never been a victim of phishing attack. That doesn't mean that it never happens. It's a $1 billion market, the attack market, I would say. Yeah. So this company is trying to solve that problem by building your personal inbox, a vault where your financial documents will come and land directly into your inbox, right? So here, so when you so if the file, let's say that I'm a HDFC Bank customer, and HDFC Bank is sending me a financial document, let's say my account statement or my credit card statement, it lands directly in my inbox. It doesn't go to my Gmail, right? Example. Now, if it lands in my inbox, then it is actually encrypted with my public key, and the bank has my public key, and I have my private key securely stored in my device, in my mobile phone or tablet, so to speak. And as in when I get my data, I can open it. But even though somebody is a platform provider, somebody has built the solution, even that entity cannot do anything because it is end-to-end encrypted, right? So there is this platform service provider who built this platform, but since the data is encrypted, right, even though that storage space that I'm talking about could be in AWS or whatever that I have subscribed to, I as a platform service provider, and I give a small space, let's say 5 GB to you as your inbox, right? So I have in a way access to that storage vault, but can I do anything? No, I cannot, because it is completely encrypted, end to end encrypted. Bank encrypts and you get it. You can decrypt it as the end recipient, right? Now, this is secured itself, whatever we have discussed so far, it is very well secured. But is there a use case of blockchain here? Not yet. But this business, this company wants to facilitate other use cases on it, right? To give you an example, if I go to VFS Global for a Schengen visa and they ask me for my account statement, etc., now, today, the way it happens is I have to print my account statement, go to the bank, ask them to put a stamp on it. And probably that is something I can do myself, right? Go to the market, spend 50 bucks, get the stamp done, put the stamp on it, sign it something, and then give it to a VFS Global. Probably they wouldn't be able to figure out whether that's a genuine document or not, because there is no way they can, right? They're not going to your bank and asking them, that did you really issue the statement to Bikram? So that is something that is not happening at this moment, and that will be very expensive and time consuming as well, right? You can understand. So that doesn't happen, right? So this doesn't mean that there is no way we can enable a verification mechanism. That is where probably blockchain comes into picture. Okay. Or tomorrow, let's say I want a loan, right? Today, you must understand that when I go and apply for a loan, the documents that I submit, it goes through a verification process. Okay. When I say verification process, it's completely manual, because there is no proper way to digitally validate those documents. Thanks to DigiLocker today, that in India we have the validation mechanism in place for a certain kinds of documents, but not all still, right? And there are other countries as well where, how do you really enable a digital verification on the click of a button? If I am able to verify the document that you have submitted is genuine, is legitimate, then there's nothing like it. I would really happy to have such a solution in place, right? But right now there is nothing, because of which banks are they have almost 10 layers of manual verification. Can you imagine? And the amount of money that they spend hiring people who would manually validate. And then even if you manually validate it, there are still chances that you might miss out on a few, and there is a fake document submitted and you approve it as genuine, right? There is a possibility because of the manual errors, right? So how can we really come up with a solution which is very quick, very fast, completely secured and completely verifiable, auditable, and it happens in the click of a button, and there is no extra time needed, right? How do we enable that use case on this platform? This is where blockchain comes into picture, right? Because we do not want a single party, the company who built this solution, to say that, hey, Bikram got genuine documents, I am the platform service provider, so I approve of it. If I say that, probably a bank or VFS Global or the UK embassy wouldn't really approve of it, right? So we want a system where people have equal say on it, not everyone, not a single entity that owns it. So what is the solution? Let's say that all the banks maintain a lightweight blockchain node, I, as the platform service provider, I also maintain a node, and then VFS Global, because people apply for visas, etc., day in and day out, so they also maintain a node. Okay, when I am getting my document from HDFC Bank, they capture only the metadata of the document, and that metadata doesn't reveal anything about my document. Even not even my name, say for example, right? So if HDFC, let's say, hashes my document, right, and captures that data, signs it with its, captures the timestamp when they issued that document to me, and then they digitally sign that and put that on blockchain. And then when I go, so the document is peer to peer, right? I got the document. The document is not with anybody else. HDFC sent it, I got it, Bikram. Now I have those documents. Bikram now goes to VFS Global for visa application. When I submit my document, the tool simply extract the hash, query the blockchain, and see when was it issued, who issued it, etc. Right? Now the verifiability happens on the click of a button, right? And here, if you see, blockchain is a layer, right? So this is not a native blockchain application. It's just a layer, an additional layer to the existing platform that enables this verifiability, right? Another use case that I wouldn't dive deeper into at this moment because we are running short of time is, let's say, in the past, I was associated with the government of Andhra Pradesh for vehicle lifecycle management use case on blockchain, where you see there is a vehicle manufacturer, there is a vehicle dealer, then we have the road transport authority, right? RTA department, who registers the vehicle against a user, like engine number, chassis number. Okay, this is a vehicle that belongs to Bikram, right? That way. And then we have traffic police department, we have normal police department, then we have insurance companies who insure your vehicle, right? And we have banks who kind of give loans against your bank, right? So if somebody is buying somebody else's car, and then there are so many challans pending, there is a loan against that vehicle, and there was, or probably there is a criminal record, because that vehicle was used for some criminal activity, then I am not aware of those things because I'm an innocent person. I'm buying this car for the first time, but I do not have a good budget, so I'm buying a second-hand car. But could there be a way so that on the click of a button, because the vehicle owner authorizes me to, let's say, validate all the information about that vehicle, if I can get those information, genuine information, then this is a safe purchase for me, right? Otherwise it is so difficult unless some trusted third party comes into picture and say that I guarantee that you can see in the market there are so many pre-owned car dealers, who have come up only because this issue, somebody has to say that this is a genuine car, and we take full guarantee of its service records and traffic police records or police records or whatever, right? So somebody has to say that, only then I trust it, right? That way. So this is another use case where you would like to have a blockchain based decentralized layer where certain information are captured on blockchain, and only when somebody is authorized to access that information they can access, but whatever they get is very, very genuine, right? So this is another interesting use case that I thought I should just tell you. Now, this is interesting, right? So we discussed the use cases of blockchain first to understand where really we can use we use blockchain to solve a real world problem, right? So whatever I've discussed with you so far, I have worked on those assignments personally. There is one more regarding academic and employment records verification on blockchain, where you only capture the metadata on blockchain, so that despite people maintaining nodes, you do not really leak out a lot of information about me, right? Because it's just metadata that you have captured on blockchain, and that doesn't reveal anything about me yet. But when I go and submit my employment records, previous employment records, or my academic document to Infosys, because I seek a job in Infosys, say for example, they can on the click of a button verify, right? So you see that by maintaining or by building such a blockchain network, the academia, because they don't have to print those hard copies, right? It's very, very expensive, right? All your semester records, etc., right? And they are at an advantage by maintaining a node. Then we have the corporates, right? Infosys, TCS. I'm sure you understand how much money these companies spend in validating your background, right? In which college did you pass out? What all companies did you work with? And that is so error prone and time consuming and costly. You see, having a blockchain based network really addresses that problem. So these are the genuine use cases that I thought I should tell you, so that given new problem, you can think through and understand if blockchain can really address those problems or not, right? Now, on the screen that you see here, in the continuation to those use cases, what I would like to tell you is there are two kinds of blockchain use cases that you build. Okay, one is a blockchain native application. The other is something that coexists with other internet application, right? And most of the applications, the use cases that I explained to you are those hybrid applications where you have a legacy or conventional application and you are just building a blockchain layer on top, right? To facilitate certain use cases, to take your existing solution to the next level, apart from Bitcoin, because Bitcoin is a blockchain native application. Okay, right. Now, what happens when you download and install your binaries on your laptop? Say, for example, you want to be a part of Bitcoin network or Ethereum or a different use case. You download a wallet, lightweight wallet. So we will discuss about these concepts later. But when you download, what happens? It gets installed on your system and it works. So this means what? This is an application layer protocol. This is so all these blockchain applications more or less they work on in the application layer, because your TCP/IP protocol stack, where does it reside? It is a part of your operating system mainly, isn't it? Right? When you say socket, when you say IP address, etc., right? Only the physical or layer or the data link layer, that is in your Ethernet card level, right? In the firmware and the card where those layers are implemented. After that, the rest everything is there in your operating system. It is a part of your operating system, isn't it? So any blockchain application that you're writing, that you're building, it is pretty much consuming the same TCP/IP protocol stack. So that is something that I wanted to explain to you, that it is a application layer protocol. Okay. Right. Now, just to recap, you see that this is on the left side, a typical client server architecture looks like this, right? Where you get requests and you get responses from a server. And on the right side, you see there is a blockchain based system. And this blockchain based system, or it may not be blockchain based, but let's call it a decentralized system, but there is no center in the middle. You see, there is no center that services your request, right? But still, the system works. So let's summarize. What is blockchain? Blockchain is a peer-to-peer system of transacting anything of value. So anything of value. What do we mean by that? Bitcoin. It has some value, right? It has some intrinsic value. That is why we are able to transact that on blockchain. Land records. It is another famous use case on blockchain, right? So land record has value. Vehicles can be transacted on blockchain because it has some value. Likewise. So it is a shared, decentralized, distributed, and open ledger of transactions that we already discussed. This ledger database is replicated across a large number of nodes. It is an append-only database. So this is very important. There is no update here. Even though, let's say tomorrow, you want to build a blockchain-based system by leveraging CouchDB, okay, or a flat file structure, or let's say MySQL, right? Now we have a blockchain company called BigchainDB, based in Germany. They're doing very well, and they have built their solution on a existing database, but they've modified the code base, the binary, so that it is an append-only database, because there is no update command here, right? If you by mistake do a transaction, then the only way to reverse the transaction is to create one more transaction. There is no update here. Okay. That is how the design consideration should be for a decentralized system to be built. Okay, a system with limited role of trusted intermediaries. You see, I didn't say that there is no role of a trusted intermediary, right? I say that limited role, because there could be various use cases where you still need an intermediary. But the problem with non-decentralized solution and having intermediary is that the intermediary has got supreme power. They can do whatever they want. There are parties involved. No one, I mean, they are taking money to settle something, settle a dispute or meet intermediate, but then they have a say on it, right? That will not happen if we have a decentralized system and the transactions are transparent. So even when there could be requirements of notaries, broker, or intermediaries, blockchain systems still enable transparency and traceability. It is another layer on top of internet and coexist with other internet technologies. So what problem does a blockchain solve? A blockchain lets us agree on the state of the system, even if we don't all trust each other, because whatever use cases and the technicalities that we have discussed at a high level, this point is very clear, right? The ultimate goal is that we all need to agree on the state of some system, right? Because how much BTC in each account has, who owns which property, which account. So I said that how much BTC in each account. I didn't say that how much BTC is owned by what person, right? An account is a, let's say, a virtual representation of an individual, say for example, right? Okay, what's the current state of my program or my system or my application? Then we can all agree on the state if we all agree on the history, because there was a genesis block, there was a starting point, and then so many transactions happened after that. Probably we clubbed them in blocks and we made a blockchain out of it. Till the current time, we can all agree on it. We don't want a single trusted arbiter of the state of the world. We want some level of decentralization. We do not want a single party to dictate the terms, right? Now, this is very important to see that in the previous slides we took a look on how a blockchain system look like, how a decentralized system look like. Now, if you zoom in to one node, then every node is maintaining a blockchain, their own copy of blockchain, right? Because it is a decentralized ledger. Everyone has to maintain their own ledger. And if it is a blockchain, then this is exactly how it might look like, right? If you zoom into one node, then it is maintaining its own chain of blocks. You see, this is blockchain. So if this is blockchain, there is a genesis block, and then what you're doing is clubbing a lot of transactions into one block, and then you propose that block, and then there is block 2, block 3, block 4, and block number, let's say 10,000. There is a chain of blocks like this. If this is blockchain, then what's the big deal, right? Now see this. This is a decentralized network. Probably you in Bangalore could be maintaining a node, somebody in Mumbai, somebody in Singapore, somebody in Hong Kong, somebody in UK, somebody in Australia, somebody in Mongolia, right? Somebody in US, Canada. So Bitcoin network, to give you an example, you could be a node being in any country, right? You are maintaining a node. And then we are saying that this chain of blocks, this blockchain that you have a copy of, is completely exact replica of somebody else who is maintaining a blockchain in Canada, right? How is that possible? Because we are all techies here. We know that internet is asynchronous, right? By default, this blockchain networks, they are asynchronous. There could be latencies, there could be packet drops, there could be people trying to make fraudulent transactions. How on earth this is possible, that every node is maintaining a chain of blocks and all those are in consensus with each other, right? They all share the same copy of blockchain, and that makes the blockchain network stable, right? So you imagine there is a possibility that so many transactions are happening. A certain node didn't hear all the transactions. They had a limited set of transactions. Other node. So what transactions you hear in the network, or in the order in which you hear in the network, and I am another node. The transactions that I get, the broadcast packets that I get, they may not be the same. You might have a different set of transactions. I might have a different set of transactions, right? How really a block is formed? How really the ordering? There is no notion of a global time here, right? In the blockchain network. But how are we able to maintain an order? Block 2 and then block 3 and then block 4. How are we able to maintain that order? This network. How really this network is sustainable? How are we achieving consensus, right? This is where we need to understand those three components that we discussed, right? Game theory, we need to understand cryptography. Cryptography is the backbone, I would say, of blockchain network. and then the third item is computer science fundamentals, right? How do we stitch them all together and make a blockchain application out of it? So in Ethereum blockchain, I'm just jumping the gun here because running short of time. Uh, Unlike Bitcoin, which is a Bitcoin network, right, only supporting cryptocurrency use case, we have Ethereum blockchain, and that allows you to build any application, not just cryptocurrency. You can build your own crypto token. You can launch your own ICO, initial coin offering. You can build a D app for stock trading. You can build a D app for land registration, for e-voting and whatnot. So Ethereum blockchain allows you to do anything and everything. And what is the technical differences between Bitcoin and Ethereum? Why is it that Bitcoin allows only cryptocurrency use case? And why is it that, how is it that Ethereum, who is actually inspired from Bitcoin, but then a lot of changes have happened of late, how is Ethereum able to support so many use cases on blockchain? So that is something we can discuss later. So I give you a hint of what a private blockchain or what a public blockchain is all about. Public blockchain is something which is public. You and I can join or leave the network at any time. And the private network blockchain networks are very private. In private networks, ideally we have two flavors. One is pure play private, where even if, let's say, Walmart wants to dictate the terms, but still there is transparency in the system. If somebody is a part of that system, even though it is a private blockchain that Walmart has built, and they pretty much do anything and everything that happens in the network. But it is, they are able to maintain transparency, so that you trust eventually Walmart, because they are not doing anything as per their whims and fancies in their data center. It is a blockchain network where there are other parties involved, and they are able to maintain transparency in the network, right? And then the other flavor of a private blockchain is a consortium blockchain, where not a single party has a say on it, but a consortium of different entities combinedly have a say on it. To give you an example, in India there is a company who is building a bank chain. The use case is like, if one bank is doing KYC for an individual, let's say I'm a customer of Axis Bank. If I have done my KYC done by Axis already, then tomorrow if I go to IDBI or some different Canara Bank, then do they have to do the same steps again? It's redundancy of work, right? I mean, there is no point doing the same KYC again. So why not build a consortium where everyone benefits from it and save some cost, right? So this is another example of a consortium blockchain, right? But it is not public. If you and I want to join the network, we cannot, right? Because it is a consortium. Right. So current state of blockchain, we have blockchain as a service on IBM Bluemix. We have Microsoft Azure hosting and giving away blockchain as a service that you can consume from. We have SCP Leonardo, which is also offering blockchain as a service. We have Oracle offering this solution. Huawei in China offers this, and Amazon, who was initially denying that they wouldn't have a blockchain-based solution, today they also offer blockchain as a service solution, right? Okay, so any question I can take on? We still have a few minutes.
Bikram, there are two questions came in the chat window. If you can see, it's from Rukhsar Ahmed.
Okay.
Like, if you want, I can read.
Yeah, please read it.
Yeah, the first question is like, are the blockchain network have only one ledger shared across all the nodes? Like you showed
Okay.
one slide, right, where all the nodes were having the same blocks. So I believe at that time this question came in. So are the blockchain network have only one ledger shared across all the nodes?
Okay. What's the second question?
Second is, can we redeploy the D app from Ethereum network? Currently, Azure blockchain doesn't provide any option to redeploy or delete the D app. So this is the second question.
Okay.
Can we
So
delete or redeploy the D app? Yeah.
Okay. So the first question first, our blockchain network have only one ledger. So it is one copy of the ledger, but it is not one ledger. So it is like, to simplify it, let's say you're Rukshar, me and Kasam, we all are maintaining this blockchain network, and we have our own, ledger with us. When I say my ledger, I can very well screw up with it. Okay, I can do some more additions, or I can do anything, but it will not be in sync with other replicas that, let's say, Rukshar has it, right, or somebody else has it in the network. So that means what? They are different copies, but but in consensus with each other, right? They are these similar or the same copies. Same copies is an ideal scenario, but you can very well get obsolete, right? So that means what? It is not one ledger get distributed across. It is like one ledger, and the copies of that ledger is with everyone, if that makes sense. Yeah. So the second question is, can we delete or redeploy DApp from Ethereum network? Okay. So it is like every time you are doing anything with the blockchain network, right? If you want to deploy a app, you want to build a D app on the Ethereum network, then it is more or less a smart contract that you have written, right? And every time you do it, you are actually, if you are redeploying it, then you are actually changing the entire instance, right? It is a different instance now. It will have a different account generated for it, right? When you deploy a smart contract on Ethereum, because you are talking about redeployment, right? So it cannot be the same thing again. You cannot change the existing one. That is a pain point that I can agree. Okay, but if you redeploy it, then the instance gets changed, right? So if you want to redeploy and have the same thing, then there are different ways you can do. But I mean, I will have to dive into a lot technical stuff on how exactly Ethereum works and how we can do that. But yes, I mean, can we delete or redeploy? No, that is not really how it should work. Okay. Then I see a third question. Yeah.
So sorry to interrupt, Bikram. So for example, right, when we write a smart contract, and might be initially when we start, we have some couple of features, and now we want to enhance also that smart contracts. So how can we achieve that in blockchain by deploying the DApp? Because it is a software, right? At the end, it is
Yes.
a smart contract. It is use case or the workflow.
Yes.
So how can we achieve that?
That's a very great question, I would say. Excuse me. That's a very good question, and that is not really how a blockchain works, unfortunately. Okay, but you can make your system modular by dividing your application into multiple smart contracts. Okay, it is like the smart contracts can communicate with each other, and it could have a modular deployment. But adding those features and doing things like that, it is extremely difficult in a blockchain network. Okay. So this is where we usually advise a on-chain and off-chain approach, where we say that for the auditability or for the track and trace of certain things, we should use blockchain network. But then the entire heavy lifting should be done off the chain, because maintaining the code base, adding new features to it, that becomes very, very tough. And there is a way. So basically, if you want to really change it and it's a private blockchain, then you can fork it. You can create a new instance where every party has to agree on it. Because if you have, let's say, the bank chain consortium blockchain that I spoke about, right? So if you want to have another feature added in, you could very well do that. But then it actually changes the state of blockchain, and that is, if that is something that the network can agree on, then they can do that. Yeah.
Yes, because if we deploy a new instance, right? So there's some transition already happen on old instance. Then
Correct.
we have to leave it as it, right?
Yes, absolutely. So for this backward compatibility also, let's say that when you're migrating from one blockchain to another, it can be developed in a way so that that is possible. It is doable.
Okay. And
okay. But we will park that for the Ethereum session, because it is like we haven't even discussed what a smart contract is and what a hard fork or a soft fork is, right? So this is something that we will park that for later session. But this is a very nice question. And this is actually something that the industry needs to understand in doing it right.
Yes, yes. So, okay, thank you. Regarding the first question, as you mentioned, right, every node have the copy of ledger, right? And that ledger
Yes.
have the blockchain also, number of blocks, or that is what is replicated or added in blockchain. Now, for example, if hacker hacks that particular nodes, and
Okay.
he can things from the that, because each machine has all the required information, right?
Yes. Correct.
Okay.
Yeah. So if I get your question right, let's say that you're
ये
someone. Let's give you a name. Let's say you're
मम्मी है
Dave.
क्या ये
Okay.
तुम्हारी मम्मी भी ऐसी
Guys
strength है
who are not a part of this discussion, kindly mute yourself. There is a lot of noise. Yeah. Okay. So let's say that you are Dave and you made a transaction to Charlie, and I'm Bikram. I'm maintaining a node, and I have all the required information. As in, I hear all the transactions that there is a transaction being made from Dave to Charlie, right? Now, having the transaction, can I? Let's say that it was of 10 Bitcoin. Can I make that 20 Bitcoin? No, I cannot do that because the transaction is digitally signed by you, by Dave, right? Now, even if that machine is hacked, let's say that machine is in my machine, I'm Bikram, my machine is compromised. Now, somebody has full control on my system. Now, obviously, they are accessible to the information that I see. But then to get that information, you need not really have Bikram. Just maintain spin off your own Bitcoin node or Ethereum node. It will sync up with the network. You will automatically get all the information for free. You need not hack somebody, right? But now the question is, despite having full control on my system or maintaining a node, blockchain node on a Bitcoin or Ethereum network, what harm can you do is the question, right? Now you cannot forge my signature or Dave's signature because Dave has its corresponding private key, right? So you cannot really make any changes. Now, since my machine is compromised, my name is Vikram, let us assume that my private key is also compromised, right? Now, with that, what can I do is I can try to redo one of the previous transactions, which I cannot do because everyone has a copy of the blockchain, right? I cannot go back and change something in one of the previous blocks. It is very compute intensive for me to build a new blockchain because we didn't discuss that part, but every block contains the hash of the previous block's header. Okay. Now, if I have to maintain that, then I have to keep hashing, solve the cryptographic puzzles, and build a chain of blocks, right? Which is now different from it was initially. But now you see that there are 10,000 nodes, and I am one node, Bikram's computer, which is hacked, and this is a completely different replica of blockchain. Who would believe me when I say that everyone has a copy of the blockchain, right?
Hello.
Not in consensus. So I'm out by default. Hey, this is the new latest blockchain. Now other
Bikram, your voice is breaking, like you are not audible.
oh, so hello.
Yes, Bikram.
Yeah, can you hear me?
Yes, the last sentence we heard was who can believe me, and after that it was
Yeah,
all yeah.
all right. So now, since I have made changes to my own replica of blocks, right? Now it is a new chain of blocks now because the hashes are completely different from what it used to be. Now I'm completely of my network. All right. And there are other 999 nodes, so to speak. To give you an example, my blockchain is very different. Now, who would believe me, right? Who would trust that whatever chain of blocks that Bikram's computer has is actually the legitimate one and we should follow that? That is not going to happen because the rest 999 nodes are in sync with each other and they have the same replica of blockchain. So I'm out of sync by default. Okay. So there is no advantage in hacking into my node, and because you cannot really do anything fraudulent. Yeah, all you can do is if I have some remaining cryptocurrency with me, then you can spend it to your account. That you can do if my private key is compromised. But just because Bikram's computer is compromised, can you do a harm, any kind of harm to any other transaction? The answer is no, because you do not have their private keys, right? You do not have their credentials, and because of which harm anybody else on the decentralized network. Okay.
Okay. Yeah. Thank you, Bikram, to explain. It's very simple. Thanks.
Yeah, you're welcome. So there is one more question. When a system is offline at one node where it's performed the transaction, how it will be in sync with current state and current value? So if a system is out of sync, offline or went down, then they have to get back in, right? And when they come back in, they have to sync with the rest of the network. The question is, how do they sync, right? So they have the existing list of active nodes, and the DNS, with the help of DNS seeds, they can check what is the current state of the blockchain, and they can download the latest copy and start from there, right? It's a matter of downloading the current state of block and starting from there, right? And offline where it performed the transaction. Yeah, now if you're asking about what if I just made a transaction and then went offline, right? So if my transaction is genuine, I made the transaction and I went offline, then it doesn't matter, because my transaction is broadcast in the network. There are people who heard my transactions, and it is a genuine transaction because I have signed it with my private key. So if it is a genuine transaction and I have given a mining fee for it, then some node will definitely try to include it in their when they try to propose a block, and it will eventually go through. Now, the parallel on a parallel note, what I would like to tell you is, to create a transaction, you need not even maintain a node, right? If you are let's say that I'm a part of the Bitcoin network. Let's say I own 10 Bitcoins. Does it mean that I'm maintaining my own node also? No, right? People who are maintaining nodes, they are rewarded for maintaining their node, but I am owning Bitcoin because I see value in it. I want to make some money with by trading Bitcoin. I just have to maintain a lightweight wallet. Okay, so my lightweight wallet is a software basically. Okay, wallet software. So if I have a lightweight wallet, it doesn't sync the entire 100 or 150 GB of transactions from the network, but I can still make a transaction, right? Okay. Hope that answers this question. Next is how multiple copies of blocks gives consistency of a single record. Okay, how multiple copies of blocks gives consistency of single record. So I'm assuming that your question is how multiple copies of the same blockchain. What is the need of having so many nodes maintaining the same replica of blockchain, right? How does it really help? It helps in decentralizing the network, because if I say that only 5 computers are maintaining the blockchain network, then it is very easy for me to, let's say, hack into 5 computers. But if I don't even know how many nodes are maintaining blockchain network, right, then it is very difficult to hack into. At least if I can hack 51% of the network, then I can have a say on it. But that is astronomically compute intensive. Okay, so it is not in my best interest to spend so much of compute and etc. and hack into so many different machines and get a control on the network. That is practically infeasible. Probably that is the reason Bitcoin is still not hacked. Okay. Then the next question is, are offline transactions possible? Excuse me. Now, if I get this question right, are the offline transactions possible? If my laptop is not at all connected to the network, then if I make a transaction using my wallet software, will that be heard by the rest of the nodes? No. No one hears this transaction. If no one hears this transaction, then this transaction never happened. Okay. So that means that offline transactions are not possible. But if you intend to have a different question, or probably you wanted to ask something else, then please ask again, because if it is air gapped, it is not connected to the network, then how can it be heard by other nodes in the network, right? Any other question?
Yeah, Bikram.
Yeah, please go ahead.
Yeah, Bikram, how we will maintain the data security, like the personal data, is what is being maintained in the GDPR. So, like,
Mhm.
if you remember the occasion that has happened, like the Snowden had given all the informations what the NIA and the other intelligence agencies were tracking down using Google servers, Facebook, and various other servers. So,
Mhm.
how that can be handled using blockchain?
Okay. Okay. This is actually a very deep topic. Okay. This requires a lot of discussions as to what needs to be done. But there are a few things that I would like to tell you as pointers. Okay. The first thing is, in the blockchain network, we do not really keep all the information. Okay, especially the personal information, even if they are encrypted. In the financial documents use case, imagine that if I say that all the financial records will be encrypted but kept inside the blockchain, and every node will have a copy of it, probably I would prefer that my documents are safe with Google or Microsoft as a centralized entity, and instead of that having with everybody, right? I wouldn't really prefer that. Excuse me. So I wouldn't prefer that. So I would say that we would use blockchain very wisely, because there are scalability issues also, and keep only minimal information on blockchain. Now, coming to the GDPR stuff and coming back to protecting your identity information should be kept with you and you alone. Okay, but you should be able to verify that. I mean, you should be able to enable verification of those information on blockchain, right? So the verifiability aspect needs to be put on blockchain. Okay, that is another pointer that I wanted to give you. What it means is that, to give you an example, if I want to go to a hotel tomorrow, and instead of giving my driving license, which has got my permanent address, this has got my date of birth, right? I do not want to reveal that information, because it is not something that the hotel company intends to capture, right? All they wanted to know is that, I am above 18, say for example, and I am an Indian citizen, etc., and or who the person I am that I say I am, right? So if I am really that I'm claiming to be, then that information needs to be verified by the hotel. Now, there are other alternatives to verify, to get that information very validated on blockchain. Probably I can use a zero knowledge proof technique, so that I can prove that I am an Indian citizen. I can prove that I am above 18, but you need not know my exact date of birth. You need not know my place of birth or my permanent residential address to know that I am an Indian citizen, or I belong to, let's say, Karnataka. You need not know that. So with so the idea is to prevent information leak as much as possible, right? So zero knowledge proofs can be maintained in the form of smart contracts, or it could be maintained offline, I mean off chain, not on blockchain, where certain computations and tasks are taking place off the chain, but few information, the verifiability. When I say verifiability, I mean that, let's say I have the hash of some certain information on blockchain, just the hash of it. Okay, so hash is not reverse computation of the hash is not possible. So I'm able to prove that such an event happened, or I was issued this card, or I was issued this information from the government of India, right? And this is a genuine information. You see the digital signature attached with it. So all I'm trying to say is verifiability needs to be on blockchain, right? You should be able to enable that verification is possible on blockchain, right? But not the other way around. Not keep the data itself on blockchain. Okay. So this is a very deep topic, and there are so many facets to it. There are so many dimensions of discussing this problem, and it has been a pretty interesting problem. And there is a lot to discuss on it. Time is just not enough, is what I can say. Any other question?
Yeah, Vikram.
Yeah, please go ahead.
In continuation, Ruksar was asking.
Okay.
So, can that be possible? Like, if like you said, like people are there in the blockchain, or 1,000 nodes are there. So let's assume that if at least 100 nodes are a kind of hackers, and they are trying to manipulate, or like they are trying to psychologically work on, or trying to trust of the nodes as well. So like there has been some transactions which is being done, and these 100 nodes are like giving a go for that, no, for that transaction. So is there any like possibility that the other hundreds, or maybe other 200-300 nodes may also give a go for the fraudulent transaction, and that way it can be like the 51% of the nodes give a go to this particular fraudulent transaction, and then it happens. So like,
Well, this is
of this kind of thing happening in the blockchain.
no, this attempts could have been done to make something like this, but this does not. This is not really that feasible as we speak. The reason is that, even if there is a 51% attack, can you still forge my private key? You cannot, right? All you can do is you can try to double spend. Okay, it is like the money that you have spent in the past. Okay, if you this is where we need to understand how really Bitcoin works in the context of Bitcoin. If you want to discuss, then the way it happens is, if you have spent a transaction already, then you cannot spend the transaction again to prevent double spend. Okay, because there is no closing balance funda in Bitcoin, right? So everything is there in the form of a transaction. So if, let's say, you're Manoj, I'm Bikram, I made a transaction to you of 10 Bitcoins today. Okay, and you have not spent it, then that is called a UTXO, on unspent transaction output. Okay, that is there, and every node maintains it uh, for processing for processing the transactions faster. Okay, so every node maintains a list of, let's say, UTXOs. Now let's say that you want to spend the transaction to, let's say, somebody else, to Vinod, say, for example. Okay, you are Manoj, you got 10 Bitcoins, and that is a part of the UTXO. Now you want to spend that 5 Bitcoin to Vinod, right? So if you spend 5 Bitcoin to Vinod, then you have to assign the remaining 5 Bitcoin to yourself, and that creates a new transaction. Okay, where you got 5 Bitcoin from yourself, and that itself is a new transaction, and that is a UTXO now, that you can spend later. You see, there is no funda of closing balance here. So now that is also there in the form of a transaction. Now you can spend that transaction later in the pipeline. So you can have hundreds or tens or thousands of UTXOs like this from different accounts with different key pairs, right? With different key pairs, you can get different transactions, and you have to sign with your corresponding private key. So this is the job of your wallet software that can help you do this in a seamless fashion, right? Now that is how you spend transactions. Now, to answer your question, if there is a 51% attack, then what can you do? You can at best try to undo a transaction that happened before, right? Because you cannot still forge Bikram's signature, you cannot still forge Vinod's signature, you cannot still forge Manoj's signature, right? Because their private key you cannot still generate. But all that you can do is, handle or try to redo, as in you can say that the transaction never happened, right? Or something like that. Or you might try to double spend, say that it's still a genuine transaction, because majority of the nodes are saying it's a genuine transaction. It could still be genuine, right? But you cannot still forge Bikram's transaction or Manoj's transaction, even if there is a 51% attack. Make sense? Okay.
So Bikram,
Yeah.
one of the slide use case you have mentioned, the proof of exchange and proof of authority and proof of information. Can you just tell something, what exactly that it is, like proof of concept or something else?
Oh, no. Proof of concept is when you want to prove a concept, you want to build a lightweight application. But in that
So,
slide,
yeah, proof of work. Sorry, proof
no.
of work.
Okay, so proof of work is a sort of a consensus mechanism that is there with your Bitcoin network. Okay, the reason we have a proof of work consensus is because
No,
I do not
so,
want.
sorry to interrupt. I'm
Mhm.
just asking. In one of the slide, you mentioned proof of exchange or proof of authority and proof of information. Are
Okay.
those similar to proof of work or something else?
Oh, no, not at all, not at all. Good that you corrected me. So basically, I'm not talking about proof of work as a consensus here, but in one of the slides that you see, I can read it out to you. There are three information that I was capturing, and this is related to that secured enterprise consumer communication, where files are being shared from, let's say, financial institutes like HDFC, Axis Bank, etc. Right? And it comes to you as an individual to your inbox. Then what is it that you capture on blockchain? I said that you are capturing some metadata on blockchain, right? And what could be that metadata? Proof of existence, proof of integrity, and proof of authenticity. Okay, proof of authenticity means that it is from Axis Bank and not from somebody else, right? So authentic as in source verification is possible. Somebody, let's say VFS Global, trying to verify, they can verify that this document was actually issued from Axis Bank, and it is an authentic document. Okay, first thing. Second is proof of integrity. When I say authentic, I mean that it was issued by Axis Bank, right? But did I make any correction to it? Did I added an extra zero to my account statement? This is where the integrity comes into picture, right? Where we take the help of hashes, because we have captured the hash of the document. So any space or a light dot that you put inside your document, it is going to drastically change your hash. The hash will not match anymore, right? So we are able to preserve the integrity of the document on blockchain. The third one is proof of existence. Existence as in it existed in the blockchain network at certain point in time. So I said that you're also capturing the timestamp. When was it issued by which bank? Okay. So ideally, if I'm capturing these three information, probably I could capture more depending on the need basis. But I can say that if I have these three information, then I'm able to support this use case of verifiability of the documents, isn't it? So I think, guys, please shoot any other question that you might want to ask me offline. But we're running short of time. I have to hop onto a new call now. So thank you very much for attending, and I hope it was an informative session. And I wish you
Uh,
good luck.
Thank you, Vikram, for your time for presenting today's webinar. Yes, of course, it was very informative, and I believe many of the myths about the blockchain has been solved today. And we will be looking for more such sessions with respect to blockchain
Sure.
uh, for presenting in this for Dear Azure and AZ India community. So thanks a lot, Vikram. Thank you everyone for joining. I will be providing this recording on the same link,
Sure.
and we'll share with everyone. Thank you, Vikram. Thank
Okay.
you, everyone. Bye bye.
Thank you. Bye bye.
Thank you, everyone. Thanks. Bye bye.